Dear students, in the previous class, we have discussed the notion of a random variable, the distinction between discrete and continuous random variables. Today, we discuss the probability distribution of a random variable. That is, we define the probability distribution function, or what is known as the probability density function. Probability distribution function for a discrete random variable and probability density function for a continuous random variable. Anyway, we simply say the probability distribution function of a random variable. Now we first consider the probability distribution function of a discrete random variable, and then we consider the probability density function of a continuous random variable. Remember this. Given a variable, given any variable, we have a frequency distribution, a relative frequency distribution, and a relative frequency histogram for a discrete random variable and also for a continuous random variable. We have a frequency distribution, number of times that particular variable take values, dividing with the total frequency. We have a relative frequency distribution, and if you plot this in the form of a graph, we have what is known as relative frequency histogram. Now, relative frequency distribution or relative frequency histogram of a discrete random variable gives possible values of the variable and the proportion of times each value occurs. That is, if the variable is x and if relative frequency x value 2 5 times, then the relative frequency proportion of times, say 0.05, 5 times, the value is 5, relative frequency 0.5, 0.05, 0.1, etc., etc. This will give relative frequency distribution and this graph relative frequency graph. Now, using the language of probability, we can extend the notion of relative frequency distribution and the relative frequency histogram to any discrete random variable, the notion of relative frequency distribution and the relative frequency histogram, which we have defined in the context of a variable, can be extended to any discrete random variable by using the terms probability distribution and probability histogram. So, probability distribution and probability histogram are analogous to relative frequency distribution and relative frequency histogram. This is defined for a variable. For a variable, this is defined for a random variable. Random variable. Now, what is this probability distribution? A probability distribution is a listing of possible values of the random variable and corresponding probabilities. The listing of the possible values of the random variable and corresponding probabilities of a discrete random variable or a formula for the probabilities, or simply probability distribution is nothing but a listing of the possible values and the corresponding probabilities. Then what is probability histogram? A graph of the probability distribution. A graph of the probability distribution is known as a probability histogram, analogous to relative frequency histogram. As we can have a relative frequency distribution and its graph, we have a probability distribution and its graph for a random variable, and specifically now we consider discrete random variable. Now let me give a formal definition. Let X be a discrete random variable. X be a discrete random variable taking the values x1, x2, etc., xn. X is a discrete random variable taking the values x1, x2, etc., xn. And let fx is the probability that x is equal to x. Fx is the probability that x is equal to x. Then fx is called the probability distribution of the random variable x. Fx is called the probability distribution of the random variable x. More formally, fx is the probability that x is equal to xi, I is equal to 1 to n, equal to 0 if x is not equal to xi. So probability distribution is fx is the probability that x is equal to xi, I is equal to 1 to n, is equal to 0 when x is not equal to xi, is called the discrete probability density function of x. Discrete probability density function of x, or simply the probability distribution of x. If x is the random variable taking the values x1, x2, etc., xn, fx is the probability that x is equal to x is the probability distribution of the random variable x. More formally, fx equals the probability that x is equal to I is equal to 1 to n, is equal to 0 when x is not equal to xi, is known as the probability distribution of a discrete random variable x. Now, the function fx can serve as the probability distribution if two conditions are satisfied. Fx is greater than or equal to 0. Second is sigma fx is equal to 1. Fx is greater than or equal to 0. Sigma fx is equal to 1. These are the two conditions to be satisfied for fx to be the probability distribution function of the discrete random variable x. Now, given that fx is the probability distribution function of x, let us give an interpretation of probability distribution. As we have stated earlier, probability can be defined in various ways. The one which is useful for our purpose is the frequentist interpretation of probability. The frequentist interpretation of probability. That is, the frequentist interpretation of probability of if an event is the proportion of time it occurs in a large number of independent repetitions of the experiment. And using this definition of frequentist interpretation, we define probability distribution as, is a definition, in a large number of independent observations of the random variable x, the proportion of times each possible value occurs will approximate the probability distribution of x. So, in a large number of independent observations of a random variable x, the proportion of times each possible value occurs will approximate the probability distribution of x, or equivalently, the proportion histogram will approximate the probability histogram. The proportion histogram approximates the probability histogram. To clarify this, let us consider a concrete example. Actually, the probability distribution is nothing but relative frequency. Suppose that this is the mark received by the students in an examination, and absolute frequency, relative frequency, 0 to 9, 10 to 19. This is a discrete random variable, 20 to 29, etc., 90 to 99. Absolute frequencies are 0, 0, 0, 10, etc. Total number of students 200. Divide each absolute frequency with the total, then 0.05, 0.1, etc. 1. Now, mark is a random variable. Actually, mark is a variable, but as mark is not predictable, mark is a random variable, and absolute frequency is the number of outcomes of a given event. That is, the event mark between 0 and 9, number of events 0, 10, the mark between 30 and 39, etc. That is absolute frequency, number of times, number of outcomes of a given event. Then, relative frequency is obtained by dividing each by the total frequency, is the probability if number of trials is sufficiently large. So actually, for our purpose, we simply define relative frequency as probability distribution of x. For our purpose, if the number of trials is sufficiently large, this relative frequency can be interpreted as probability distribution. And it is in this sense that we use the concept of what is known as frequency distribution. Frequency distribution is nothing but relative frequency. Viewed in this way, marks obtained by the students in an examination, number of soft drinks sold from a bakery, the number of accidents per day. All these are random variables. And we can assign probabilities to each events or set of events, and dividing the total with each with the total will give you the relative frequency, and this is nothing but the frequentist interpretation of what is known as probability. So probability distribution is nothing but relative frequency distribution for our purpose. Let us consider one more example. Suppose that is an example we have considered earlier. Number of siblings. It's a discrete random variable taking the values 0, 1, 2, 3, 4. Frequency is 3, 17, 11, 3, 1. 40 students in a class. Relative frequencies 0.2, 0.405, 0.275, 0.075, 0.025. Then probability that xi is equal to x, that is of x, is 0.2, 0.405, 0.275, 0.075, 0.25. Total is 1. Total is 1. So remember this. This is the relative frequency, and this relative frequency is nothing but the probability distribution. And if you draw this in the form of a graph, you will get the probability histogram as P, then 0, 1, 2, 3, 4, like this, then 0.2, 0.4, 0.6, like that, then 0, 0.2, then 0.4, then point like this. And this is what is known as the probability distribution, and this is the probability histogram. Probability histogram, where probabilities are taken on the y-axis, the frequencies, the values taken by the variable on the x-axis. So this is the probability distribution of a discrete random variable. And remember this probability distribution of a discrete random variable is same as the relative frequency distribution. So probability distribution is used in the place of relative frequency distribution. Probability histogram is used in the place of relative frequency histogram that we have considered. This is probability histogram. If we plot this, you have what is known as the relative frequency histogram. Now, associated with any probability distribution is its cumulative distribution function CDF. Cumulative distribution function CDF. Associated with any probability distribution is its cumulative distribution function, or simply the distribution function. And for a random variable x, the cumulative distribution function denoted as fx is the probability that x is less than or equal to x. We can define CDF as capital letter Fx is the probability that x is less than or equal to x. Probability that x is less than or equal to x means the random variable takes a value less than or equal to x, where x is given. Say up to 1, up to 3, up to 5, etc. And this CDF is only the sum of PDFs for values of x less than. So fx is equal to, probability of x is equal to x is equal to sigma fx. X is equal to sigma fx, because let it be here up to a specific value of x. To be for convenience, let's x takes the values 0, 1 and 2. Suppose that fx is 1 by 4, 1 by 2, 1 by 4. Then fx is nothing but 1 by 4 plus 1 by 2, 3 by 4. Then 4 by 4 is equal to 1. Then in the form of a graph, fx, x, when the value is 0, 1 by 4, then when it is 1, it is 3 by 4, then when it is 2, it is 1. It is like this. This is 1 by 2, this is 1 by 4. So it is like a staircase function for a discrete random variable. For a discrete random variable, the cumulative distribution function is a staircase function. It is like this. And cumulative distribution function is required for our future purpose. So this is the distribution function and cumulative distribution function of a discrete random variable.